Hello everyone and welcome to Building Budgie number 5. Building Budgie 11 number 5. In this stream, we are going to be working on the integration of WL output, which is sort of one of those core Wayland protocols, into our Budgie desktop services. This Budgie desktop services is a daemon that runs in the background. It's actually, if you're using Budgie 10.10, it's actually running in the background right now. And it's going to handle a wide variety of things as an abstraction. But one of the key things that it handles at the moment is persistent display configuration. And it does a lot of this through the protocol WLR output management. And I will go ahead and see about swapping to, let's see. We will swap to this camera, and when I swap to this, there we go. All right, so I could show you the protocol a little bit if I fire it up. WLR output management, which is the current protocol that we use. So we get information from the compositor, for example, LabWC or Wayfire and that sort of thing, on information about the output head. So you could think of an output head as traditionally a monitor, but of course it doesn't have to be in the spec, but generally speaking, in a desktop metaphor, it's going to be a monitor, whether that's like an external monitor or like an output or display on a laptop, right? Sort of the internal EDP. So you get information about like the name of a description, you get the information about the modes that it has, like so the different resolutions that it supports with different refresh rates, the positioning and the transformation, and so on and so forth. And you're able to configure it, in particular the output management protocol. Well, it's for managing. But the problem is that this protocol is only supported by effectively, I mean, you could see it's a lot of compositors, but a lot of them, for example, Wayfire is listed here, LabWC is listed here. These are ones that are based off WL roots, which is, well, where the WLR output management protocol comes from. And that's all well and good. However, if you are running, for example, or you are developing a mirror-based compositor, and this is a bit hard to see, I know, but if you are building a mirror-based compositor like I am doing with Magpie, then the key thing that you have an issue with is that it doesn't support out of the box the WLR output management protocol. And you know, you could just say do what Miracle WM does, which is add support for it. I'm not going to, because I'm not actually that big of a fan of the protocol. I actually prefer the KDE output management protocol more, at least from a high level of what it supports. And basically, I don't want to implement it. So we still need to get information about outputs because, well, I want to start launching elements of Budgie shell. So this is the Budgie 11 shell on the right output. And in order to do that, you have to have information on it. You have to have information like what it is, right? Its identifier, where it's positioned, and so on. And then be able to call the respective Qt outputs. So the goal is to try to move us off of WLR output management protocol for all these like readers. So all the things that we need for reading, for getting modes, for getting the name of it, manufacturer information, geometry, so on and so forth. And we are going to do that by leveraging K-Wayland like we do already. So K-Wayland we have integrated because it handles the connection thread and the registry, and it makes it really easy to constantly get new information from the compositor, because having to manage that connection thread yourself is a bit of a pain in the butt. So we leverage K-Wayland for that. I don't think it's actually a KDE framework. It's just something that they develop, and well, they haven't yelled at me yet for using it, so I suppose it's probably okay. So we are going to be leveraging their direct support because they support a wide variety of protocols in K-Wayland, including the one for WL output. And that provides us a lot of very handy, cute interfaces for things. For example, getting geometry, getting the model, getting the manufacturer, the physical size, refresh rate, and so on. And then also they have classes. I can't seem to access it through Qt Assistant, but they have like a dedicated mode class as well, which has information about the modes. So that's going to be your height, width, refresh rate. So they have information on that, and they actually make it really, really easy to, like, they have really good documentation on just how to create those outputs. So we need to take our sort of meta head object and integrate support for the WL output, and then hooking up events and so on. Because right now, a lot of it, if I go here, this is the WLR head, right? So I actually have it under BD outputs WLR in this WLR section. And this meta head itself is actually under WLR. I'm not going to try to do the refactoring of this to be moved up a level in this stream. But what I do plan on doing, if I open up the header here, is adding support for, because right now we just have head point to WLR head. I actually want to have head point to the WL output, and or something to that effect. We'll have to see how the implementation goes for that. So that way, most of these getters that I have, like height, make, aim, etc., can just translate over to using that instead. Because right now they get it from, if I go, for example, name, you can see it returns mname, which is a member that's set. And we could go mname is equal to, and you can see that we get it from a set property here with a constant of a value. So we could start mapping out, for example, when we get this changed event, which is emitted when data changes. And conveniently enough, it's, all the data is available as well when you are listening to that changed event. We could hook it up to set properties and do it that way, or something to that effect. I've thought about this a little bit. Whether or not it goes as well as I'm hoping remains to be seen. But that's the goal. That's the goal. The tricky thing is going to be able to figure out how I map a WL output to our meta head. Because it's one thing to, I could add a function for setting the output, right? Because right now we have one for set head here, which we use. I believe we use, if I do set head, you could see, yeah, in our output manager here, we iterate whenever we get a new head from ZWLR output manager v1. We check if there's an existing head. If there is, we set it. Otherwise, we construct one with a null pointer. So this is a brand new head, and then this is our normal one. We check if there's a head available, and then we do the set head. So basically, this is just ensuring that all the information about the head is available. So a lot of this code will be able to be simplified. We'll see how that goes. So yeah, it's it's one thing to sort of think about this at a high level, but it's another thing to actually have to write the code for it. So if we go back to our output manager, I believe this is where we are setting the registry, or maybe it is in state.cpp. Yeah. So this is where we initialize our state related to outputs. So we create our K-Wayland client registry, and then we basically pass along the connection thread from the application that we have. And right now we're listening on a custom interface because K-Wayland doesn't have support for ZWLR output manager, which there's no reason why it should. because, well, there's nothing in K-Wayland that would be leveraging it. So there's not really an incentive for them to add it, and there's no incentive for me to add it because I'll just be supporting the KDE one anyways. So, but right now we check if that interface exists, and when it does, we create that output manager with the registry and the interface version. So I am thinking that the first thing we'll want to do, because we have these done events and head events, is we're going to want to create, I think, our output manager regardless of whether or not we have this interface. Because the output manager is what is responsible for, well, obviously managing the outputs, but it has a bunch of getters here for applying and for applying objects and heads and getting output information. Let me expand this a little bit, and I could probably shrink this down a little bit too. I don't need that quite yet. And for getting the output head, where we iterate over, so we pass in a string and we check if the identifier matches that string. So like some of these helper functions here. So we are going to want to rate that regardless. And then if I check over here, so we create a WLR output manager, which is also another thing. Like there's, I mean, I intentionally did this where like I knew way in advance. Like I have a, when did I create this issue? Maybe I don't want to know. I created it 2 months ago. So back in February, I knew this was something I was going to do. And what I had done, if I go back to, let's see, outputs. Yeah, it was this monstrosity. So 43 files changed in this, where I moved a bunch of stuff into a WLR. You can see here, I moved a bunch of stuff from outputs into like a general reorganization. I think it was this commit anyways. Let's see. Yeah, I think it was. So I knew in advance that this model wasn't going to be sustainable, and I also wanted to support multiple methods of, or multiple different protocols, whether that be WLR, KDE, because obviously I can't just add KDE support and then drop the WLR one, because then, well, you can't use Budgie desktop services and on Budgie 10.10. And we kind of need to maintain compatibility. So right now, all the meta related stuff and output manager, all of it is designed around WLR, and it has been. So it's going to take some prying to sort of reshape it to be generic. So that might be what we have to do immediately, which is a little fun because we have this WLR output manager here, which takes in the registry. Why does it even take in the registry? But it does m registry. Why? Do we use the registry anywhere? We pass it into, right, because we pass it into the ZWLR class, which is generated by the dbus stuff. There's QDbus CPP gen. So we have that, but we pass in the registry, which is the WL registry to it. Instead it casts in, okay. But I don't know if we actually need to hold the reference to it. I suppose it doesn't really matter at this moment. But that creates our output manager, right? And then what we do is we override some of the events. So you can see here from the parent class. So these are the things that actually get called. So when we have a head here, we then call our function, which is here. Same with finished and done. So in the case of head, we try to resolve the identity. So we take in that WLR head and we iterate over our meta ones. So you can see here, there's a list of our WLR meta heads. We get the value of the WLR, so actually the WLR head. So conveniently enough, I actually already have a dedicated getter for that. We check the value, so if it has a value and if the value is equal to that, we basically say, okay, well this one matches, right? And then we set the head and then we return. Otherwise, what we will do is we'll create a new meta head, because presumably we haven't seen this before. And then we are going to connect that all up. So we have a head available. So if I go to the CPP here, head available, or is this on, okay, so it's on meta head. So this is emitted when we set the head. So we create that, we basically say, okay, it's available, and then we hook up a bunch of functions on the head. So we have like this head finished, and that is called when all of our modes, if I do head finish, actually no, that's when it's actually finished. It should be, when are we doing the construct? Property change, add mode. Oh, it's probably on the set property. Set property. Yeah, we have a bunch of these, and when it's shim mode, we immediately save, which kind of has bitten us in the ass, to be honest. We're being a little too aggressive with those with the saving in shim mode. So, some context: I have something called a bash system. Because with the way the protocol is designed, the WLR output management one, whenever you make a change to a single property, so say for example, I am changing the resolution from 1920 by 1080 to 3140 by 2560. So when I'm going from 1080p to 4K, you would think, oh well, I just need to send off an event that says, hey, I'm changing the mode of this output, and that's it, right? And it changes the mode. No, you have to communicate all the information. Otherwise, it's a protocol error. So even if it didn't change. So is adaptive sync enabled? If it's not, well, too bad. Like, did that change? No? All right, well, too bad, you have to admit that anyways. I'm trying to think of the other properties as well that have to be emitted. But regardless, you have to emit a bunch of the properties. Yeah, set position. Did the position change? It might have been that you only have one monitor and you're changing it, and the position is 0, 0. Well, too bad. You have to do a set position explicitly as 0, 0. Transformation. Well, maybe you changed it from 1080p to 4K, and you didn't rotate it at all, right? It's not part of the same transaction. Too bad, you have to omit that. And throughout development, this bit me in the butt too many times, because I was only emitting, say, set mode or set custom mode, and set position and set transform and set scale, but maybe I forgot set adaptive sync. And suddenly it's not doing anything. You're wondering, like, what the hell? Why isn't any of the information, why isn't my output changing? So I created a batch system that does a few things. One, because we already know the state of the actual head, we only need to be informed of what we actually want to change. And right now that's over dbus. So if I go to, I wonder if it's actually still installed dbus. It is. Dbus. If I go here and I go to, oh, maybe I actually intentionally, no, it's here. I know it's hard to see on it, but I will describe the tree. So basically at the top level, we have org, Buddy's a Budgie services outputs, and then we have information about the individual outputs. So these are the serials. So it's like 0x30, 32, 39, blah, blah, blah. And then you have information that you could get over dbus about that. Well, say you want to just change the information on that output, right? So you would change it, and then you just basically commit So that's under a config here. You would say set the output scale, and you don't have to send anything else over the wire. And then in the background, in the batch system, we compute things like anchors, and then anchors are like the positions, like the literal X and Y positions, calculated based off modes and resolutions and scales, and then all of that. And it sends it over the wire. Well, that actually worked, but the problem is we wanted to ship Budgie 1010. So there is a shim mode that effectively just, as soon as we get new information about a head, about an output, we save it to a file. This is actually going to bite me in the butt. I need to actually, I gotta just be easier if I do it here. QString, no op, or Josh. Oh, it's not QString. QDebug. No op, or Josh for now. So we're gonna do that. We're gonna return, and we are going to take all this, and we are going to do this. Comment it out. Oh no, I don't want it to delete all that. What the heck? I'm gonna have to remember that. So all that long story was basically my way of saying we have the shim mode. Whenever we do a change, it immediately commits it to a file, and it also immediately, well, does the change, right? And if I'm saving it to a file during testing, like while I'm testing things, and say it didn't get information, suddenly it reports my resolution while we're working on this is like 00. Well, this monitor is then going to be 00. But if I don't save the file, I could fire it off as much as I want, and it should be okay. So we'll see. I did perform a backup of my config though, this shim file that I have. If I do a cat on .config budgie desktop. If I go to display config-shim.toml, you can see we have a bunch of like different groupings, which are auto-generated. So you can see here when I have this two monitors that I have 3840 so 3840 by 2160 at 59.997 hertz. X and Y is 0, and then you can see this is my right hand side monitor is offset by on the X side by 3840. So there's no overlap. But I have all of that, but of course, the identifiers are going to be different, which is going to be not great because we don't get serial information. I was looking at the documentation. We don't get the actual reported serial. Presumably that's actually because it's generated by the compositor, if I had to guess, which is like it's a unique and persistent value, and then we extrapolate based off that. But fortunately, I already have code in place to handle that. So when we are trying to identify the output, we could do it based off the model. So it's actually get identifier. I go to that. We have this function where if we have a serial, we'll use that. But if we don't, then we will construct, we try to create a unique value. And this unique value is based off the machine ID. So if you're on Linux, this is usually from like reported by D. Well, it's exposed anyways by dbus. I don't know what generates it. I would assume it's systemd, because what doesn't systemd generate? But it's unique to your machine. And then the name of the actual device. So this is typically like HDMI 1, DisplayPort -1, that sort of thing, which fortunately doesn't really change. Like it's a bit of a pain in the butt if you have two display ports, like I do. Well, like I sometimes have had in the past, where it'll like mix up DP1 and DP2. There's not really anything I could do about that. It's sort of just a try your best situation, but maybe that's something that we could like hopefully is resolved with KDE output management. Crossing my fingers. But regardless, then we do a cryptographic hash. So we just basically take this unique string, which is like the machine ID and the name and the model and make and all that kind of stuff when we have that information. And we just create an MD5 hash. And then we report the identifiers that. So that part should be fairly plug and play. We just need to make sure that we are not going to be setting that information from WLR. So what I expect is the first thing we'll want to do is probably related to output management. And actually, let's write this down. Let's open up KWrite or something. Create a new thing here. And let's go ahead and we'll enlarge the font as well. So let me just type test and then that is big text, but let's see, to do for stream, right? So the first thing is related to probably output manager, which is WLR, to meta head, WLR, 3 head, WLR, and these two might be reversed. So if we take a look at this, let's start mapping this out as like to-dos, because otherwise I'm going to be bouncing like crazy between things. Now you would have expected me to do this before the stream, but nope, that's not the way I'm rolling with this. You get to see all the development unfiltered, for better or worse. You also see me take a sip of my energy drink. Right, so we have this output manager, which is, let's actually put this BD outputs WLR output manager. We have that. All right, so the first thing is we need to, do we want to move it up a level? Because I feel like we might want to have, so open question, do we want a higher level output manager with WLR1 being specific to WLR operations? That is the first open question, right? Because this is going to dictate what changes we need to do for the output manager constructor. Because right now we pass in the UN serial, UN32, which is the serial which points to the protocol, and the version. So it's actually easier to see down here. And then we basically construct the ZWLR output manager with the registry, the serial, and the static cast, and then we have a couple overridden functions. Because I don't really want a high-level output manager to be a child, actually to inherit from ZWLR output manager v1. Because, well, for obvious reasons, we might not be able to actually create a ZWLR output manager v1 if we're not actually on a compositor that supports it, right? So in that particular case, I mean, it's really looking like we are going to want to have a higher level output manager and then the lower level one, which maybe does some resolving here. But then we have like WLR meta head. Do I have to move that out? And then it's like, do I need... I haven't quite figured out the whole like dynamically determining which compositor type we're on, like what is supported and what we return. Of course, the other option is that we have a output manager that defines like an interface effectively. And then you have like that, and that's the high level. And then maybe you have something that overrides it. Well, that implements it. I mean, either implementing the interface or you just have a class, a generic class with expected interfaces. And then some of them are no ops. That is also an option. Because we have like this apply no op configuration thing, which is a bit gnarly. Also, it's not formatted either, which is kind of annoying. There we go. Did that actually clean it up? I did. Oh, so good. Yeah, because we have like configure, which creates a new configuration as well. Now, fortunately, we don't have to. I don't think we have to worry about this yet. Where we just admit that it succeeded or not, which is kind of funny. We enable, we append the head, or we disable the head, and then we return those configuration heads. I wonder, are we actually using this? Really? Are we? Okay. Applies a configuration that does nothing for each output. Are we not using this in the batch system? Is this a dead function? I mean, I guess so. Like, I'm not seeing it anywhere. I don't think I have any filters set up. No, it's just straight up don't. Okay, so I could just rip this out then. This is to ensure we don't create... Right, so I'm guessing I fixed this with the batch system a while ago and just never cleaned it up. Well, we could fix that up. There we go. Alright, so that's nice. Let's see. So we do this, we create the meta head, we know when it's available, and then we emit, and we set the head. Like, so this we already covered. That's fine for now. Done, emit's done. So if we check, I want to check the batch system. Which I keep calling it batch system, but I think it's actually configure output state. Yeah, so we have a bunch of different matching groups. And then we apply on a matching group. Oh, I just did a pause. I wonder what that does. Apparently I just did print screen as well. All right, well, good to know that keybind's working. Right, so we get, so on a group apply, I still call it batch system here, even though it's it's output model. Right. It's been a while since I renamed these, so where is this actually located? Outputs config model. Outputs config. It's here. Okay, right. This is sort of a rabbit hole I'm getting into, but I just want to double check the logic here. Yeah, so we have the orchestrator, we get the manager. We process each of the outputs. If it's on, right, so we then, okay. So we have our manager config, which we call enable on, what is this? Configure. So we are actually using configure from output manager. And that is just creating that configuration object. So that provides that. At the right, yes it is, okay. Yeah, so it's the Wayland, I mean it says Wayland output configuration, but in reality it's our ZWLR output configuration v1. Output states, so we will do a calculation result, We get all the output states, and then we iterate over all of them to make sure that they have a respective target state. If they don't, we skip it. If it does, then we will, if it's on, do a enable, and then do a bunch of different logic on it by getting the position and then do, okay. So yeah, we just, when we implemented that batch system stuff, we just ripped out. Okay, great. So that no op is not useful. So that was able to be removed. That's quite nice. Actually, let's do this. Check out, do I have a dedicated branch for this before I start committing crap to it? And reference. Can I generate one? Oh, this is something I quite like about GitHub as opposed to Forge.io. So this is, I would say this is a feature, and it's issue 26. All right, so we're gonna do checkout feat slash 26 dash integration of WL output support. If I check this, yeah, I don't want to commit the state.cpp changes. I just want to commit outputs. So we're going to do that. There's going to be chore, cleanup, dead code, dead code, or apply no op, and WLR output manager. We'll do that. And we'll just go ahead and push that immediately. Assuming my keychain stuff works, which I did fix. But all right, good. All right, good. So we have that. All right. And then we just have the finished stuff, and then we have done, which just sets the serial, and then sets true that it has it. And it's done. Let's look for done. I'm just trying to mentally map out because it's been a while since I've looked at this code. Right, so in our meta head, that's not what we're looking for. We are looking for this, output manager done. So when we are aware that the output manager is done, at that point in time, we then inform that the orchestrator is ready, and then we start up the dbus session, because there's no point in starting it up when you don't have information about the outputs yet. We register it, and then what we do is register the individual dbus services for, yeah. Oh shit, is it actually on the meta head path? It is. And then within that, we do it for the modes. Okay. Right. Oh, it's, oh man. I dug myself a hole with this one because so much as this is tied up with the, I mean, I think if I could generalize output manager enough, then that might be okay. But of course, the problem is that the ZWLR, that the actual output manager is set to basically be a child of, we're supposed to inherit the ZWLR output manager v1. Which you know, because I've mentioned it like 5 times. As you can see here. From Cute Wayland, where we create the registry. So what we would want to do is have like a high level one, I think. The done and head added, like those would be the generic ones, right? So if we, let's map this out below here. So if we have like a a generic. Wait, why is it doing it there? Generic output manager. This would just be a queue object. Queue object. And this is basically an interface, right? I don't know if we actually need this serial. I feel like that, I don't know, we could add it anyways. Let's do this. Let's create the top level. We'll create generic. We'll just call it generic om.hpp for now. Pragma once. I'm gonna do namespace. BD outputs. We have a class called output manager. Public queue object. Right, something like that. And then this is what would expose queue underscore object. Is it meta macros? No, I would include that. Got that, and then A is public. I'm just trying to map this. So we have output manager. That would take in these two, I think. Would we want to have an interface that exposes the serial? Let's take a look at the KDE output manager. So it's going to be... I wonder what they call it here. But surely they support it. Is it Plasma? Oh, that's Plasma window management. Maybe it's not in K-Wayland. I find that kind of hard to believe, but let's see. Plasma, there's just literally nothing related to K. Oh, okay. Is it up a level? Oh no, back. All right, well, we won't worry about that for now. K-Wayland, we'll pull that in. We have that. Does it need to have a configure? What does the configure do? I guess that does a configuration object from WLR. I'm just trying to see if there's a way I can make this generic enough that we could have like a high level one, and then when we're under WLR we would instead I guess when the interface is announced in the registry we would know to create that one. And if everything gets announced and we don't have it, we create the generic one. And maybe we could set a flag of like, you know, XYZ supports WLR or whatever. And the generic one would not support configuration. So it would be a no op. But it still has to return something, right? Because if you check the output manager, it does a queue pointer to configuration. So we would want something that, I guess, also has a generic configuration interface, which I don't really want to start doing yet. Could it be a standard optional? Oh, how do we even do that generically? I don't actually know. Because, like, for example, I hate to use this as a reference, but like TypeScript, you just do like T, right? You'd like returns some type of T. T could sort of be anything. Or do you have it return like unknown? And then heads would probably be, I mean, right now that's like meta heads, but that would change. These two we definitely would have. This, I mean, I feel like these two are a no-brainer that we would have on the interface. And then the WLR one would implement this generic one. So we need to include this, but of course this is down a level in WLR. To do Josh Stroll, generalize meta head. Because the idea is like everything's just creating an interface for this. Or it's satisfying an interface. We have signals that we're going to want. We're not going to be doing any protected things here. And then private, we would have all these properties. Right, so then you would have instead, so this is a public BD output manager from generic OM. Missing be here or something, yeah. And these are all overrides, right? Configure, oh, that one is gonna be. I wonder if there's a way of, because I'm not terribly familiar with C++, obviously, to check if it has that. Has to configure, and then calls that if it's available. But for now, we have all these. We don't actually need to expose these. It's just overriding them, I suppose. Override. Only virtual member functions can be marked as override. All right, well, let's see how does it work on this. So they have a class, so they are virtual classes. Or virtual functions, I mean. Yes, let's see, C++ virtual. Oh, there it is. Multi-inheritance. This is probably what I'm looking for. Oh god, no, maybe it isn't. What the fuck? Dreaded diamond thing? What? Yeah, here. Protected ints. Okay. That's just I have to Google this. Well, not Google, but this is actually, does this even have any functionality? I feel like it does. Protected. Let's see. A virtual function is a member function that you expect to be redefined in a derived class. When you refer to a derived class object using a pointer or a reference to the base class, you can call a virtual function for that object and execute the derived class's version of the function. Virtual functions ensure that the correct function is called for an object regardless of the expression used. See, suppose a base class contains a function declared as virtual, and a derived class defines the same function. The function from the derived class is invoked for objects of the derived class, even if it is called using a pointer or reference. So here they have an account, they have a checking account, a savings account, so they have a virtual destructor, a virtual get balance, a virtual print balance, and a private here. So they have that. A checking account takes in a double and passes that parameter of D to account, which is then set as the balance, and then print balance will do a cout of get balance, which then is just returning balance, of course. Because they aren't defining, they aren't overriding that. But I guess you don't have to do an override of it. Yeah, so that is call print balance using a pointer. Right, so they're basically casting it as an account and then calling print balance. Because it's virtual, yeah. So both of these would actually call this. It wouldn't call error, I guess. If a class is declared that does not provide an overriding implementation of the print balance function, the default implementation from the base class account is used. Functions in declared classes override virtual functions only if their type is the same. A function in a derived class cannot differ from a virtual function in a base class if it's return type only. The argument list must differ as well. When calling a function using pointers, blah, blah, blah. Resolved, called a non-virtual, is resolved according to the type, right? So these are both void, so that's shared shared returns. Right. So if you called derived, calls the virtual function. This is a non-virtual. Overrides of virtual functions are always okay. Yeah, so we would have a high level account. So if we have our generic OM here, these would be virtual functions. These would effectively all be virtual, actually. The signal would not, though, I don't think, because it's still returning the same, like emitting with the same value there. But I guess in that case, you don't even need to define an output manager here in the WLR one. Like, I don't need to define these. It's a redefinition. Like these overrides here, I don't think I need to do that at all. Same with the signals. Configure, I still have no idea what the hell to do about that one. I feel like that also. Because the problem is that returns configuration heads, which themselves are the ZWLR output manager ones. So, like, turtles all the way down with this. So it could be that we have instead, I hate to do this, but virtual configuration. This is include WLR/configuration. Because a shared pointer, if we just don't have that implement anything, right? Like it just returns a null pointer to that, then the code can check if it's a null pointer. And if it isn't, it would just consider it a no-op. Something like that. This doesn't know. Conflicting type, did you mean WLR? Yes, I did. WLR. And actually, this is true. I don't need to define all of these. This is too verbose. There we go. That's better. So we have a generic output manager here. And then we would have configure here. I guess we would want a destructor. We don't need any of this either, which is great. So the WLR one is effectively the output manager. And then, let's see, clean these up. And then three events that we override. So let's see about changing that. We have our generic OM. I'm not going to do the implementation of them yet. Although I have the heads here. Might actually need to do it already. Shit. All right, let's rename this then to output manager. I have two output manager files, but whatever. So we have that. And then this needs to be renamed immediately as well. It's kind of funny that it didn't actually handle that. But. So this is our high level one. And let's actually then do this output manager.cpp. And let's go ahead and close. I don't need this open yet. Close that. So we're gonna have the WLR one up top, generic one at the bottom. We're gonna do a pound include on output manager.hpp. And we're going to do namespace, PD outputs. And then we are going to define our class here. So it's going to be our output manager. And I do not feel like retyping all this. So we're going to do this. Bloop. And the registry. Oh yeah, but I guess the constructors are different. Do we need the serial conversion? I'm not convinced that we need those, to be honest. Whatever. Let's add it for now. I really don't think we need it, but I want to keep these constructors identical for now. So we have that. I'm going to do QObject of parent. And this is M registry. Actually, we could just link these, right? Something like that. And then here, we are creating a QObject. So actually what we're going to want to do here is have it create a output manager. I actually want to even be really... Oh, wait, no, I can't actually just do output manager. Right? Maybe... we'll do it like this. Output manager. And this is going to take in parent. It's going to take in registry. If I could type it, of course. it's going to take in the serial and the version, like so. And we're going to rip out all of this because it is not required. So we have that. And we have all this stuff. It's a private. Oh, right. It needs to be protected, I think. So. All right. There we go. Hey. It's private. It's only available to its class, but protected. It's available. Visual Studio. No, it's Z. Oh, or you mean this? Also, hi Neil. I'm Pepega when it comes to C++. So I needed documentation on how to do virtual functions and stuff. I haven't had to deal with this since like, oh god, middle school. So probably like what, 20 years ago or something. I don't want to think about it, all right? It's been it's been a long time. Try to create a generic interface. So we have our WLR1, so that's all fine. But what I want to do, so we have this configure. Out of line definition. Is it though? Well, what I do need to do is have output manager. But the IDE itself is Z. If I doubt you're asking about that. But you know, in case you were. Configure. And this is supposed to return a Q shared pointer WLR configuration. And this is actually going to return a standard null pointer with the Q debug of output manager does not support configuration. Like that. Expected function style class. But isn't that like a Q shared? Hold on, I have to look this up. Q shared pointer. So let's see. Let's also increase the font size. Oh, it might actually literally just be you create. Right. The object is holding a null pointer, so you just literally return Q shared pointer. I kind of like it like this. Of course, it has no idea what the heck to do about that. Q shared pointer. Something like that. Right, it's how you do it, right? I don't think you need to do it like this. Where's it pulling it in from? Right, it's create. What am I doing wrong here? Why brain not smart? I just look at Q shared pointer. Right, because I'm not defining the type. Dir. Like that. There we go. That way it's null. And Q shared. So this is, we actually could just port this over. Turns M heads. Like so. Get output. So this could be ripped out. This is probably okay for now. And same with these. We can move these over. Like so. Because ideally, only this should be returning. Output manager. Maybe the... I already had this open here. Oh, right. I don't have it defined here. Out of line definition of configure does not match any declaration in BD outputs WLR output manager. Do I have to actually override it? I wouldn't expect that I need to. But I guess because I have custom logic, I guess I do. I would do override. Right? That gonna work? Okay. So we have that and emits a done, which is going to be the parent's done. And we have set head here. So we still have custom logic, which handles the handling of that. The creation of the meta head, which is a thing. Wondering what we need to do there. Because our generic one, I feel like our generic one should be handling the event, which is actually just in the registry, isn't it? For output announced. So emitted whenever a WL output interface is announced. And then you create the output, which is here. Because up at the top, you can literally just create it with the registry create output function. Have that. Oh, you could actually get an output from a native one. No, that's quite handy as well. Because I would want the get heads to return a generic head. Meta head, actually, is what I would call it. Although, actually, it would just be head. Because the whole thing with the meta head, the reason why I did that is because we actually have a dedicated... well, I guess if I didn't have it be removed. So I did this meta head and meta mode logic because I didn't want to lose the information. For example, when you unplug a monitor, right? Let's just assume that's the case. You unplug a monitor and suddenly in dbus you can no longer re-enable it. Or say you just disable it, you turn it off. Well, that output gets destroyed, which removes its reference. So then you can't re-enable it. It's really dumb. So I implemented meta head, and I did the same for meta mode. Because when you disable a head, reasonably, it disables all the, it destroys all the output modes. And well, you kind of want to be able to re-enable the head and then point it to a mode and have it still work. So I have all these meta objects that hold references and information, so I know those don't get destroyed. And for the most part, it actually works quite well. At least when I've used it with the batch system. So I think I still need a concept of a meta head, which has information. But then the question is, where? Oh. The meta head, I wonder if that could hold a reference to the output. And its functions return the information from the output by default. I'm thinking. We still want it to be a head though. I feel like we don't. I feel like having it be a meta head that stores the information from output would be okay and holds a reference to it. Let's map this out as well, similar to what we did with our generic output manager. So if we do a head here, head.cpp. Well, actually, but we'll call it metahead.cpp. So we are going to have a, I assume I'm going to need a Q shared pointer, and I will definitely need to include Q object here. Have namespace, ed outputs, and then this is going to be a class of meta head. So let's take a look up here what we're doing. So this is going to be a, oh yeah, because I had the protected QDBus context. Oh right, I did it this way. Uh-huh. Yeah, in order to actually make all the Q properties exposed by, like, over dbus, I did it this way. I forgot about that. And then I have a bunch of different functions. Okay. That actually would be kind of nice, because then I could have the same dbus interface, and then that would, like, get the information based off the WLR1, or maybe. Have all this. We have identifiers, and then yeah, we have this get WLR head. Right. I mean, I guess I would just cast, right? Like if I know I'm in a configure function or something under the WLR output manager, or in the model, so the what was previously called the batch system, then if I know I'm under that compositor, I could cast them over to being the WLR meta head. And then I know that the get WLR head is available. Something like that. Set primary, set relative output, horizontal anchoring, unset mode, dbus registration. Yeah. We would want basically almost all of this. Let's pull in QDBus context. Like so. Adaptive sync. What does adaptive sync return? A uint. What does it return for KD? I have to look up the KD output management one. KD output management E2. I think it might be, let's see, a mode transform on an output device, right? So we were looking at adaptive sync. Which in our case, I guess, would be VRR policy. We need to compare this to this. Adaptive sync is a adaptive sync state of 0 and 1. Okay, I mean that's not so bad. So like the enums are pretty close. So we could just have it as a uint. Okay. And then I wouldn't want, so I would want, let's do this public like this. And then this would just return the uint. Do I have a uint32? Or is it literally just uint? Just uint, okay. Uint. Rather than like forcing it to have to be transformed into adaptive sync, in which case, if it's automatic, then, well, it's not going to work. We are going to do adaptive sync here. Right, so we have something like that. Mode. Q shared pointer of that, so we also need a meta mode as well. To do Josh switch to a generic meta mode. But for now, we'll do it like this. Because I don't know what the actual... I have to check what the interface looks like for the one that's provided by K-Wayland for output mode. Because like it doesn't seem to be something I could easily select in Qt Assistant anyways. Which is fine. Because it's not really intended to be that much of a user-facing library, I don't think. Let's do this as well. So we have this. I'm also going to turn up the music just a touch. So that way it's... There we go. Okay. So we get the head, which is the WLR head. I don't want to implement that. Where is that used? Get head. Dot get head. What? Really? Okay, well, we could just rip that out. That's unused entirely. Get output. Mode for head. So this is used in model. Ah, right. So that is getting the, based off the width, the height, and the refresh rate, the meta mode. Get mode for output. I really don't like that naming. I'm gonna do Q shared pointer, PD, outputs, WLR for now, meta mode. To do. I will do it like this. And I'll do it as get mode for dimensions. Although it's not just dimensions. By props. Someone is welcome to come up with a better name. And then we have get modes. Yeah. Right. And then we have all these, which are constants. We have that. Map to WL transform enum for the transformation. Okay, so that's another thing we have to look into. So what does the transform do? So transform on this side and transform. Here we go. So it's 0 through 7, and they are identical. Is this the right? Wow. Lucky us. But what is it for WL output? Is it a transform? All right, I guess I have to open up here as well. WL output. Out. Oh, right, it's clear up here. Okay. So if I do this and throw it here, one over here. There we go. Transform. WL. Oh wait, or is it mapping to Oh, it's because they all map to a WL transform. Ah, okay. Yeah. I don't know why I was thinking that it's maps to like some WLR value. All right, so yeah, then we could yoink all of these. So why the hell would we want to? Why don't we just return it as that? WL. Let's see. WL. Output transform. Enum. It's probably actually transform. No, not from K. It's from K Wayland, I think. It's client. I don't think that's right. Transform. Output. That's. Huh? Output. Transform. So what is the mode then? Mode. Subpixel. Okay. Yeah, we'll do transform. You should be able to. I would assume you're able to construct it just because it's a UN. So that needs to be a const as well. So we'll do transform. Const. I just put peg at that. There we go. So that would rip those out. Get identifier is a bit of a fun one. Use string identifier. So it's used by the serial property. Oh yeah, because really? Why did I do it that way? I mean, it's not too late to make a break-in change for this. No one's consuming it. I really just prefer to call it identifier, not serial. I'm gonna do it. Because in WLR, you have a serial, right? But just the normal WL output, you don't. That's why I had that get identifier. So I am actually going to call it identifier. Identifier. Read identifier. Identifier changed. Here we go. All right. So we have this get identifier used by serial. I have to look up the code for this because this seems weird. Serial. So it recasts our why wouldn't you just do this? It's not marked as a const, right? I see. So we're doing a const of this just to do the identifier. Right. Because the dbus stuff expects them to be const. Kind of sus, but all right. So this we are actually just going to call it get identifier then. I think. What does this do? No, yeah, I mean it's not a constant value. That's the thing. We're just lying to it with the const cast. That's okay. I see why we do it as serial then. Okay. I still want to actually call this, maybe it could be called identifier, and then we have just an internal function, like a, we'll have it as like a, do this. It's not going to be this. It's going to be up here as identifier. And then identifier is going to call get identifier. Get identifier. So actually this is kind of, these are useful. Internal. Do that. All right. Get position, which returns a Q point, and how fortunate, because actually the WL output one for its geometry is actually what it does. Oh wait, no, there's global position, which is actually what we're looking for. So we have anchoring, which isn't like a, yeah, sure. Come on. You know it exists. Fine, I'll do it myself then. Please. There we go. We have all that. We have a bunch of setters, but well, I guess as it changes, yeah, we would need setters. But the WLR head, obviously not something we would implement, is available. Bool is available. Set head, nope. These, sure. Unset modes, yes, we would do all this, I guess. D-bus registration. We have all these. We want to grab this and then remember to change serial to identifier changed. And then change this to identifier. Like so. We have some Q slots for adding a mode. So we wouldn't be doing that. Have one for the current ZWLR mode changed. Where is that used? What? We iterate over them. The current mode changed. So, all right, we iterate over them. We check. Oh, okay, so we're effectively doing the match. So if we find the mode, we get the information for it, and then we emit that, hey, this mode has changed. Like the actual meta mode with the new information. But it doesn't seem like we're actually using that anywhere. All right, just meta head here. Why do we add this code? Why do we have this code? I don't want to delete it yet. I will comment it out though, and hopefully my thing doesn't strip comments. It does not. All right, fantastic. Head disconnect, that is useful. And then this is also useful. It has no information on the meta head property, so we need to pull that in, which is types. I think it's under types. No, that's actually output mode info. Oh, it's enums in here. Okay. Output. output slash WLR slash enums, which is used for this meta head property setting. What else? Meta mode property setting. Okay, so those actually are generic. So I want to find, where are we referencing meta mode? All this. Okay, so I'm going to move these up a level. Like so. All these like references are going to break, but that's okay. Because this doesn't really belong. Yeah, I need to change that as well. So we have that. Let's see if it's used anywhere else. Meta head property. It is on set property. So that's the actual implementation. I'm not going to worry about that. Yeah, I'm not going to worry about these yet, because we're going to shift things around anyways. Yeah, that's... Why is it complaining about that, though? Ah, right, because of the references. It's up a level on outputs slash... We have types and... Alright, that's a little silly. And enums. I guess these are... Yeah. Okay. Head is busted as well, because this should be output slash enums. Meta mode is busted as well, because it is also expecting that. And mode itself is busted. Shit. Let me close that. All right. Output slash. I'm just going all the way down the rabbit hole. Maybe I regret changing that. Not gonna worry about that. Not gonna worry. Just I'm gonna back all the way out to meta head in WLR, and this is gonna be meta head for normal. All right, let's go all the way down. We have set property, and then we have all these different private private members. So we're gonna grab these and we're gonna make them protected. So we have registry, so we need to pull in registry. So we are not going to have that as the adaptive sync. This is going to be a uint. Q point we need to pull in. This is busted. It's this. That should be fixed now. Hello. Why are you complaining? Oh, it's because mode is broken. Thought I fixed that. Nope. Outputs. There we go. You better be fixed now. Good. All right. Please. So that means this is fixed down here. M head. This is not what we want. We want a reference to the K Wayland output. Like, I feel like regardless of whether or not you're on a WLR, I mean, I know for a fact I want the WL output regardless, because otherwise why would I be doing this? So this has to exist as, say, a K-Wayland client output, and output. So that is the thing. We have M serial here, which needs to be changed to M identifier. Identifier. Oh, which already exists. So M serial will be up a level, I guess, in the WLR one. Okay, so that all looks good. So we could start ripping out all this. Adaptive sync. I think we could keep that as... no, you know what? We could rip that out. Rip all this crap out. Meta mode. Yeah, it's that has to exist for now. But could do this. Output modes. And then we have the identifier. We don't need description name, make model, and then mhead definitely. We don't need registry here. And then if we look at what add mode, we don't have as a queue slot. Let's just rip out these two functions, I guess. We have all this stuff. We do actually want serial changed here. I think. Roll. All these. Unset mode, set head is what we need available here. Get WLR head, we will want anchoring, position, serial. And then, so do we still have serial here? I don't think we do. No. I mean, what we could do is have serial on the meta head itself, and like on the higher generic one, and just have that map to M identifier by default. That might actually work. And then we could have this signal here as well. Feels a little redundant. No. Let's. We're gonna keep it here. Scale, modes, yada yada. That's all fine. Primary name. Built in. This is all okay. Get modes we have. Get mode by props. Yeah, that needs to be changed. Let's actually rename this. Like the interface itself hasn't. We'll just do this. And I'm gonna do a replace. Toggle replace. Get output mode for head. There we go. And we're just we're gonna replace all matches. There we go. Okay. Get current mode. Right. I guess our meta mode needs to map, yeah, similar to our generic meta head. Our generic meta mode needs to map to the K-Wayland one. So I mean, what we need to do that in meta mode. the functions for getting modes would need to be overridden. mlist would need to point to the non-generic one when we're at WLR meta head. Let's keep these the same for now. I get the feeling we are going to want to override these. These need to be virtual. These all need to be virtual, actually. Fuck. Oh god, I forgot to put virtual in front of these. Probably the least efficient way of doing this, but it's okay. We're just gonna virtualize all the things. So they could be all overridden if we want. Except maybe on set modes. Oh. Register dbus service? That definitely shouldn't be virtual. Q signals? I don't know if the signals need to be virtual. Same with set property. I guess we'll find out. If those are virtual, then we could override them. Get modes. Queue list of, yeah, that's fine. Only allowed on virtual members. Well, that is because this needs to be a PD output meta head. And of course it's like, what is that? What is a meta head? None of this stuff. This all needs to be ripped out. Oh shit, did I accidentally rip out the... No, I guess, yeah, it doesn't inherit from anything, so that's actually fine. The override... Get adaptive sync. I don't think that needs to be overridden. Feel like it's mainly these. I do want to try that. Serial? That's our own. Get WLR head. We have a set head because we have our own member down here for the WLR head and the serial. Yeah, so basically it's those to facilitate those two features. So that strips that down a lot. So next will be, of course, I haven't plugged in any of the output stuff for any of the mode stuff, which is something I need to do because our constructor for the meta head, I'm just trying to think how we would want this to go. Like if we think about the chain of events here, right? So we do like chain of events. We go to state. We have this, right? We connect to the interface announced. We would also want a connect to M registry of a K Wayland client registry. There's output announce as an example, right? Like we have this. In which case you'd actually do a, is it like that? Interface, output announced. It's just like connect. Let's see. Let me take a look at the registry documentation again. Interfaces, output announced. Yeah, so you want to connect up to the registry's output announced. And removed. Let me take a look again at our output manager. Right, chain events. So we go state. Create the registry. 2, state. Create generic output manager. Right? Of course, we have our WLR1. What are we're writing there? Right, it's the ZWLR stuff. Forget, do we shove the... We do. We have the head added and head removed here. Because the output manager itself is the thing that's handling that on this level. So whenever we get the ZWLR output manager v1 head event, we iterate over and then we construct that meta head. And then we push it to M heads. So that is how we handle it from a WLR perspective. But the generic one, we need to handle it. The generic one needs to be called anyways. I almost feel like we create the output manager. Right? But how do we know? Like, I feel like we still need to do it within the interface announced. Yeah, we could do it like this. So we're only assigning it here, right? So connect on interface announced. But that's as we get individual interfaces. It's done flushing the initial interface calls. This could be used to compress events. So at this point, all of the... Is it literally doing it for every single interface? Interfaces announced. Ah, but these were individual ones. Yeah, okay, so we can connect on interfaces announced. Then check the interfaces. Which points to this, which has a name. This points to a list of announced interface, which has, oh, my music ended. Let me restart that from the beginning. Which has name and version. If in the list is ZWLR, oh, I have this focus chain, ZWLR output manager v1 interface. Then we create the WLR output manager and assign it to M manager if the list does not include the ZWLR output manager v1, create generic output manager. So that's my current thinking. I want this to be Josh train of thought to MD. You know how like AIs, they have like their train of thought. This is my written train of thought. I mean, of course, I know train of thought was it's not like it came from AI. That's where I see it all the time. Yeah. So at that point, we have a manager. We know which one is which. And then in theory, it's not going to compete. Because like my concern was if we had the output manager that was listening for both, then we would have a meta head that's being created with the generic interface, and then a meta head that's being created with the WLR one. So I need a way of creating a effectively a blank slate meta head. That's kind of what this is. And fortunately, we kind of have that, right? Because it just, you create an empty meta head. All right, so that's not so bad. And then we need, but of course, the head manager is coming from this. Oh my goodness, this is such a pain in the butt. Mode changed. This would be on. To have this go back. It's really small text. There we go. The interfaces. We have output announced, but I feel like this probably has just a function for getting all the outputs. Meta whenever a WL output is announced. Plasma activated. So we might actually have to keep track of it. Or the generic output manager. Can we have it where the generic output manager is connected to that interface? I still think we would get it competing, where it would in one place be creating a WLR one, in another place a generic one. Let's continue mapping this. So if the list does not include it, we create the generic output manager. Then the trick is, from there, we need to get heads, outputs. And we are on the WLR one. We can... Do we have access to the underlying WL output, actually? On the, let's see, ZWLR, all this is going to be kind of a, let's see, can I maybe move this here? Hey, I want to have it side by side. No, fine, all right. Let's split these then. Nope. Okay. And split this. All right. So we have the head. are we going to be able to get the underlying WL output? I do love, though, that it's like, oh, the difference between these is like the output head is advertised when it's off. That is not true at all. Name, if it matches, right? So if the head matches a WL output, the name must be the same. Okay. Description, and then serial is like its own special thing. Serial number. Does not change over the lifetime, yeah. Just wondering if there's a way to... Let's see. So I could look at, if I go up to build... Actually, I think I could do it here. I could go meta head. We have this, which is a ZWLR. Sure. All right, we have the registry from the object, void, all that, all the data, scaling, handle. Okay, so it does not have a reference to that. I was wondering if there was a way that we could get the WL output with the ZWLR one. That would be really handy. But it appears that is not the case. So we would need to match it by name, I guess. So from there, we need to get heads outputs when we are on the WLR one. I'm also thinking, what does the meta head, like if we take a look, what does the meta head, or the head itself, actually need? Because we have all this generic head stuff, right? Like getting this output head. But we don't otherwise use that. We take a look at configuration head. Which is a ZWLR configuration head. Does that actually require... Where is it? It's clear down here, isn't it? Yeah, so that takes into ZWLR output map. V1 head. So we do need to have the reference to it. Iterate over these. There we need to get the heads outputs. The only way I see this working is within state. So we create the output manager, right? So at this point we have an output manager. And we create, I guess that would create this, which would then, when you construct it, let's check state again. This whole thing is a real pain in the butt. Manager. Do I have a magical function that's doing this? No, it's just a configure. Manager. From the ZWLR output head. Because this is the output manager with the registry. Yeah, right. So like then the internals, it creates that automatically, and then we automatically have those. Get the heads. So like my line of thinking is, could we have constructed all the generic meta heads with the information? But it might just be easier to maintain a mapping. And then the changed event. So let's get this out. So get a mapping of name of output to WL output. So this would be something like, we'll just say like a QMap, right? I don't think it'd actually be a QMap, but QMap of a Q string to a K-Wayland client output. And this would be on the output announced. So as they get announced, right, interface of all the well-known interfaces. I guess that would include WL output. Like if we look at the construction of this, do a registry of a bind output with the name and the version, or recreate it with the name and version. So as we iterate over this, we could have, I'm going to have to literally write like a meta function for this. Or like, scaffold it. So if we had like, pretend this is a connect. So we're like iterating. So, we have this if blah, blah, blah. Like so. So if we have this as the interfaces announced, we would do like, okay, if this, then have WLR1, WLR supported, right? Otherwise, we assume WLR isn't supported. And then we also have if interface is the one for WL output, immediately create the output set up changed events, right? Set up changed events. We also want a function for actually it's not a function, a mapping of when all WL outputs are ready. So immediately create it, and then on changed update mapping to communicate the WL output is ready, right? Something like that. So this would be part of that connect event for changed. It would update that mapping, and then what we would want is have a signal that is fired when all WL outputs are ready. Something like that. Then at this point, we determine if we need to create a WLR. Actually, we don't determine it. We create either a WLR output manager or a generic one. So we do that. And could we could we actually already create the meta heads? Record, no, because then we don't know if it's the WLR one or not. We could actually maybe preemptively create all the meta heads, like even the WLR ones. At this point, we could do this. If WLR create WLR meta head with the output set. Actually, it's, I mean, we'll just continue, but it's not technically a W output, right? W output set. Construct the WLR output manager. But of course, the problem then is that it might be enough not to do this. If it's WLR, create WLR1 output manager. If not WLR, create generic output manager. And then create generic meta heads with the WLR output. Because in the, if it's the WLR one, right? So this is like in the actual output manager, WLR output manager. Output manager.cpp handling of E1 head. I'll understand what this means. What we can do is if, so we have already, you know, like the existing head. That's not a big deal. That's not what I would be thinking about. On head available. So we create that Q pointer, right? So we create the new head. We do head available. And then we do a set head of the WLR one. We do on head available, blah, blah, blah. So actually we don't even need to worry about that. We do a set WLR head on the WLR beta head. When WLR head finished, actually it's not head finished though. Property changed is called and we get a name. We do this. Get the respective WL output from state mapping. Set that WL output to, I guess, M output. And because we know it's ready, we know all those properties would exist. And we only really need, I would say, name and serial. The rest, I think, would Yeah, they would just come from the... Yeah, we don't need to override adaptive sync or any of that because we have a mapping to the actual K-Wayland output. So this does create a bit of a bottleneck, but what it allows for is, I mean, avoiding a race condition, right? And this shit is happening so fast, I'm not too worried about it. So at a high level, on the interface is announced. So this is after we have all the information about all the interfaces, whereas opposed to right now, we do it where as the interfaces get announced, we're checking if it's the output manager one, and then we create the output manager. We don't want to do that. We want to wait until all the interfaces are announced. And then if we get information, like if it's reported that the compositor supports the ZWLR output manager v1, then we instead just flag it as WLR being supported. And if it's the interface for a WL output, we immediately create the K-Wayland output one and assign that to a mapping. So a mapping of the Q string. So this would be like HDMI 1 to that to the output. We set up all the change events, and then we know when when everything is ready, when they've effectively, the protocol has communicated all the information to the K-Wayland output. It emits that's changed also communicates the first time around that it's ready. When they are all ready, then we have a signal that we fire for that, or just, handle it in the function itself. We use the stored flag as to whether or not it's WLR supported. If it is, we create the WLR output manager, and if not, we create the generic output manager. And then we immediately create the generic meta heads with the WL output, and then add them to the output manager. That's kind of what I'm thinking for that. Maybe that's the wrong model, but I think it might be the one I'll go with for now. See as we implement it. And then in the actual output manager, the WLR output manager, we have this function for, it's an override for whenever we get information, it's announced that there's a ZWLR output manager v1 head. And then we have logic to identify it against an existing head that's not really applicable in this case. We create that meta head, and then this would actually, in this case, be the WLR one. So in the other case, it would be a generic one. But for now, we don't have that. We have a connected event. We're not going to worry too much about that, but that's basically just informing when the head is actually available. And then we set the WLR head on the actual head. So this function itself would need to change to be, let's see, set WLR head. Set WLR head. I want to change this immediately. Set WLR head. Because this isn't going to be exposed, of course, on the generic one for obvious reasons. So when we do that, we check if we're re-announcing. Sometimes that happens, but otherwise we create like a specific WLR head. We assign it to a bunch of variables, and then we have the property changed event that we listen on. And the property changed event calls the set property on the meta head that we have here. So we will actually want to port over a lot of this to the generic meta head. maybe. But of course, if we actually, no, I'm not. Now that I think about it, I don't think we will have to. Because the whole reason why I implemented this was I didn't want to emit. Do I even do it here? Emit state changed. Let's see. Yeah, we have a state changed, but I feel like we might be doing the head available a little too early. Because the idea was we wouldn't emit that it's available until we have all the properties set. But let me check the actual head. Property changed. Yeah, it's emit enabled changed. Right. If it's not changed, all right, and then we immediately save the state. Okay. We have that. Do this. Copy this over here. Ah, no, I want to copy it here. I didn't want to delete it. Oh, great. All right, fine. Don't do the whole thing then. Thanks, I guess. Oh, that's pretty bad. Something like that. Because then at least we're at the point of constructing the right meta head based off what protocol is supported. Where we go from there, I don't know yet. Yeah. Do we have a dedicated function in the generic meta head? For setting the output. I don't know if we do. Doesn't seem like it. That's all virtual. We'll do it down here, but it wouldn't be an actual... it's a relative output. That's not what we're looking for. Identifier. So this is going to be a K Wayland client output. Actually, I think it's an output like this. And then we want a M output here, which needs to be a pointer to it. I believe is what it creates. Yes. That has to exist. And then we also need one for like a getter, it would say. It's not a virtual function. Oh, these are all virtuals. I don't know quite. I definitely wouldn't want to override that. We'll just add it here. Fuck it. I don't want to spend too much time just figuring out where I want to position a freaking function. Client output, get output. Right, like that. We have this big old meta function. So the first thing we probably want to do in our state here is have a queue map. That's to a queue variant. This property getter. So if we go down here, a queue map of a queue string to a K-Wayland client output. Actually, queue shared pointer. Because I don't want to have a pointer in like 5 different places. So we are going to take this and actually put it back on MetaHead. There we go. Like that. All right, so that is going to be our M outputs. And then a queue map, queue string of a bool. M outputs ready. Something like that. M outputs. Queue map. I don't even know if I actually need to do this, but I'll do it anyways. Like so, I think. And then M outputs ready. Queue map. Queue map of a queue string to a bool. Like so. That way, they're at least initialized as an empty queue map. So we have this connect. So I think we could start implementing this. Connect on the M registry. K-Wayland client registry. Registry interfaces announced. This, and it's going to be, I would say, state interfaces announced, something like that. Of course, that doesn't exist yet, so we need to handle that. I always get confused between the whole like slot versus head thing. If I'm honest. I feel like it's void interfaces announced. Let's move this up. All right, like that. We actually need to implement it. Let's go. I don't want to lose track of all this either. So we're gonna go solve our getters. Here we go. Void state interfaces announced. All right. So at this point, we are going to get all the interfaces. So this is in the registry interfaces, which is a queue list. So we're going to do for auto announce interface of M registry interfaces. I think it's this. All right. Too few arguments. All right. Let's see. Too few arguments called. Interfaces of interface. Provide all pairs of names for a well-known interface. If it hasn't been announced, that's not what I want. Oh, shit. Interface is announced. Oh. But then I have to actually... the well-known interface for which the name will be... What? I suppose it would be unknown. I was expecting literally just... Oh, what the hell? Interfaces. I don't know, for some... I guess I wasn't paying close enough attention that it actually requires interface there to get the interfaces. So provides all the well-known interface. Empty vector can be passed into bind and yada yada yada. Interface announced. Interface. Inhibitor, idle inhibitor. Interface is announced. When it's done flushing. So I guess we're assuming the output interface would also have been emitted before interface is announced. All right, that would be my assumption. This is throwing a little bit of a wrench in. So that is like this is fine. But we need to be able to get all the outputs here. I go just all the way up. All the way up to the top, please. Compositor announced, interfaces announced. I mean, I guess it would be unknown. And then it would return all of them that are unknown. Okay. I think that would be, I think I know. Interfaces. Because that would provide all the, right, okay. I got it. My brain understands now how this will work. So, first, let's get all the outputs, WL outputs, and construct and add them to our mapping, right? So here we have interface, which points to here. So this is going to be a K-Wayland client registry. Oh, it'd help if I type that. Client registry interface. And it's going to be output. Right, so each one of these is going to be an output. And then next, we will have this is what we're going to do. We also need a Boolean. Oh, actually, I think I know what I'm going to do instead. We have these enums here, right? WL outputs, and we're going to do class compositor type. Like so, Q object. Public property, unknown. No idea what this compositor is. Then we're gonna have magpie. Yeah, right. After all, like it is our frickin' thing. So naturally, we're gonna do that. Magpie, and then we'll have WLR, WL roots. Say WL roots. KDE. Something like that. So we can at least, you know, determine that. Well, maybe we could have a generic WL roots mirror. I call this KDE, but in reality it should be Quinn. Just as an idea there, you know? And then we do a QEnum of property. I think I'm missing the semicolon there. Yeah, there we go. I don't think I need the toString from string nonsense. I'm not going to be... Well, I'm not going to be casting them into either of those, right? At least not yet. Magpie, WL roots, mirror. I mean, magpie, you know. It's mirror. Mirror based, but will support more protocols out of the box. Out of the box. Of course, that's the goal. Doesn't do that now. WL roots, yada yada. So then what we could do is in our state, we will do compositor type, compositor type. So we will by default. Is there something mirror supports that nothing else does? Mirror shell v1 listed under that. If I opened up in Wayland app, let's see. I'll laugh if it's like supported by everything. I don't expect it, but you know, it's kind of funny. Mirror shell. Set gravity. Ooh, they have mirror positioners and shit. Out positioners. Oh, that's handy. And gravity of that. Compositor support. Literally only mirror. So what we could do is get the interface value for this. So we have here. We will set it initially as compositor. Compositor type is going to be. I would like to be optimistic and say. I don't know if this actually should be here. I think compositor type should be part of the constructor. Compositor type. By default is going to be a compositor type of unknown. Right? Oh wait, no, it's property. Unknown. Like that. No, but it definitely is a thing. There we go. All right. So by default, it's unknown. We will just stick like we're not gonna go overboard yet. You know, add support for a bunch of other ones. But what we could do is so we iterate over these, and then next, check if we support WLR output manager, which is here. So we want to check the unknowns. So I'm going to do for auto announced interface. Actually, we'll do this output interface. Unknown interface. And then we do M registry interfaces. I really hope this works. Client registry interface unknown. Right? Like so. If unknown. Oh, helps if this was curly braces. If unknown interface name is equal to, I mean, it's literally this, right? Do this. And then where interface is here, we do unknown interface name. What? Announced interface is a struct, which would be a QUint field char. Oh, that should be right. Q byte array. Ah, okay, we're doing it based off interface, not name. We're not using name at all. Oh, we're using name here. Version methods of it. Name of the announced. It's not really the name of it though. It's, of course, it doesn't know that. Q byte array. Because the problem is the interface is announced when we get the interfaces. It just returns a queue list. Can we pass the bind? But if it's unknown, then it would return the unknown ones, right? Oh. I guess what I could do is interface. I would assume interface announced gets. What we could do is this. M compositor type is equal to. We could do it here. Compositor type colon property. WL roots. Indicate we are WL roots. And this actually, I mean, of course, this needs to be down a level. We create the manager there. But I don't want to create the manager there. I just want to know we are on WL roots. But of course we get the name, which is the same name. It's like the uint. It's not this interface. So we could store the interface, the Q byte array there. This would be interfaces announced. We would have this above. I don't think the order actually matters because I think it happens on setup, but do that, and then we would want probably just something here like a const a q byte array, right? Put because we need to compare that against the name. Right? Or is it that name? Oh yeah, I guess it would just be that name. QUint32 MWLR output manager name QUint32 version MWLR output manager version WLR specific. I'll do this. I don't know if really this is the best way of doing it, but that's how I'm going to do it for now. Equals version. Because all this crap could then be moved here into the, because then we don't actually need to iterate because we already know it's supported, right? So we would just do if we are oh yeah, because we wouldn't even want it here anyways. If we are not on WL roots, this would have been set during an individual interface. If M compositor type not equals M would be compositor WL roots, create generic output manager, right? And then we want a different signal, I think, for when a output has changed. So we have output manager done, interface is announced, void, KDE output changed. Something like that. Void state KDE output changed. And then if all have changed, if M compositor type is equal to compositor type property WL roots, then we would do this, right? We would create that manager. Otherwise, the manager is equal to a Q shared pointer of a of just output manager. Like that. Of course, we haven't created it, so we'll need to do that. Output auto manager is equal to new BD outputs output manager, which takes in what? The registry. So null pointer parent m registry serial and version. I guess it'd just be 0 and 0 really. So we create that. We define manager as equal to this. Saying overload there. So what is m manager in this case? Right. There we go. Fix that. Okay. That works. So we would immediately create our normal output manager. But on the KD output changed one, we check if m outputs. Oh, actually, do we have information on the output itself? Output changed. Right, so this would be Wayland client registry. I think it was output. All right, output. If m outputs, so this is output, something like that. Function definition is not allowed here. Did I break something? Ah, yes, I did. There we go. Because I don't think I need to iterate over those. There we go. If it contains output name. I mean, m out actually. We know it's going to exist in both m outputs and outputs ready. Let's do it like this. Let's start off with this one. Auto output is equal to Wayland client output. It's new. It's like this, right? Let me actually check the official documentation. Registry create output with the name and version. Okay. Is m registry create output, which is going to be the output interface name, actually dot name because it's a struct, and version is going to be the output interface dot version, like so. So we create that, which then creates our pointer. We then want to create our shared one, which is going to be on m outputs. So we're going to do m shared pointer is equal to q shared pointer. Do I even need to specify that? I guess I do. Like so. And we're going to push into m outputs the... Oh, actually, yeah, shit, we don't actually have the... We don't have the name of it yet. Yeah. It needs to be a queue list. Yeah. M outputs dot I think it's append. Right? Are you sure? What is the thing M output says? Oh, I'm sorry, what? Am I losing? I mean, I know I'm losing my mind, but... Is it just insert? No, it must be push or something. Because they have prepend. No, it is literally append. What the hell? Shared pointer. What is the thing M output says? A Q map. Oh, because I could always tell I didn't save it because it wasn't formatted. Okay, that's on me. And then what we need to do is, yeah, actually, that's also another thing is, well, we don't have the name of it. So our M outputs that are ready also has to be a list, because I mean, we could just do a length comparison. What could go wrong? Nothing at all. Yeah, we'll just do the same. We will just do the same. So do all that, and then if M outputs ready contains this, so already was communicated as ready, return. So we will consider that a no-op. Otherwise, we do M outputs ready dot append output name. Actually, it's just be output, right? So it's funny that didn't get flagged. Add to our outputs ready. Ah, but this is a because when we connect, we'll be connecting it to, and I could change it. Like I would do something like this. You append it and then you do a connect of output to our state, and it would be the KD output changed. Actually, this is connecting this, so it would be K Wayland client output changed. And you would then have this. Right? Passes reference to the context. So we would still want that to be, I guess, the shared pointer to this. Right? Because then I'm thinking what we could do is the Q shared pointer here. Something like that. Guess this would be output, I think. Actually, I want to just call it like O, because I want to see if that flags as something. Because I'm thinking it would be something like something like this. So you'd have O there. Just want to see how this works. I guess if we have a reference to output share pointer here, what is O? Shared pointer. Output. Yeah, because we would want shared pointer as a reference in both. And then I guess I could call this KD output changed of shared pointer. Cannot be implicitly captured. This and shared pointer. So we capture both shared pointer and this. And then we call that with the shared pointer. Which then goes to the KDE output changed, which is the Q shared pointer of kwayland client output. And then, you know, we have the right reference here. Something like that. Add to our outputs, and then if m outputs ready.length is equal to m outputs.length. So all of our outputs are reported as ready. In that case, we would do this. So at that point, we would iterate over. So this is m registry of, this would be m WLR name. And version, which actually is there already. So we actually didn't need to save version, funnily enough. Name we need to save, but not version. And manager, yeah, you could freak out as much about that as you want. But what I will do is this. Is going to be 0. This needs to be a queue list. Like that, and then ready needs to be a queue list as well. This is a bit of a mess, but that's okay. The shared pointer of this. Like so. You have the name. Let's check for version as well because that doesn't exist. So we get the name. We connect all that up. Something like this. I mean, there isn't really anything stopping us from doing this here. So if they are not, so if not all our outputs are ready, we're just gonna want to do an early return here. Return here. I like the inlining. So if all have changed, so if all, this is self-explanatory. We don't need this code. So if it's WL roots, otherwise we create the generic one. So we do that. So we wait for all the KDE output changed to come in. So this could be ripped out, this could be ripped out. So then we're actually just left with the interface announce. So the idea is wait for all the interfaces to be announced before we, well, and then we create all the outputs. We connect them up. It says KDE Output Manager. As they get ready, then we flag it as ready. And when they're all ready, we then create the Output Manager. So that way, no matter which Output Manager is used, then we know that we could still reference those outputs. So I'm not sure what to feel about this being a queue. I mean, I guess we could iterate over. I need a helper function then in this to get it by name. Let's see. Property getters. I'll just have it here. I don't like these not being sorted though. What? Ah, right, because it's doing it based off the... I sort by function name? No? Alright. Okay, well, whatever. K Wayland. This is going to be a Q shared pointer. Right to... Oh, I don't want to accidentally pass a null pointer though, so I'm wondering if I should do it where it's a standard optional. Because then all the code would have to check if the optional actually has a value as well. So there's a meaningful difference there. One versus the other. And with the problem with the shared pointers, then you also have to do the cast too. So I could have it be just K Wayland. Client output. Get output by name. And this will be a Q string of name. And then in state, we would do it probably like here or something. Get primary or first head. Oh, I guess we have available outputs here. Let's see. Available outputs iterates over each one of them. And then gets the serial, which should be identifier. So actually let me just double check serial. No, identifier. All right, so that was the only other reference. Get serial, that doesn't really matter. We could nuke that. Manager is a whole, yeah, that needs to be fixed. Now that's not aligned, so I need to fix get manager to point to just output manager. And that will fix this definition. I'm gonna want this. So we are going to, for auto output of M outputs. What do you mean undeclared? M outputs, right here. And it's right here as well. Ah, right. I'm missing Steam. There we go. I was like, what do you mean? If output name is equal to name, we return output. And for some reason that triggered Siri. It's kind of weird. Oh, what the hell was that all about? Otherwise, it's going to be a Q shared pointer of just all pointer. Basically like that. I mean, actually, and what I could do, I kind of like the early return, but if I did auto output is equal to this, then what I could do is assign, we'll do O. Then we'll do, it's like less clean, but O break. And then we return O output. No, that's, I don't like that. I'm gonna revert that back. Will all the Vala stuff also be rewritten? It's a ground, it's not a port at all. We're not porting Budgie 10 to Budgie 11. Like, what I mean by that is like, it's a complete different architecture. The Vala stuff is not going to be rewritten. The Vala stuff will die in a fire because it does not deserve to live. So the we really have, like, of course, in the context of Budgie 10, we've been writing Vala, but Budgie 11, all C++ so far. Well, okay, and a little bit of JS for like the QML stuff, but that doesn't really count. So it's important to remember it's not a one-to-one port. It's a fundamental re-architecture where we're splitting things out. So we have a Budgie core. Actually, there's a Budgie is a Budgie blog about this actually. Funnily enough, I can't access it in Qt system. If I go to Budgie's a Budgie and I go to news, well, of course, I think it's also in the, FAQ as well. But if I go to state of Budgie architecture, we talk about the re-architecture here and some of the pain points of 10 series and the whole separation of core versus desktop. So it's worth a read. It's the State of the Budgie 2025. And I think I even mentioned in the FAQ as well as a pluggable architecture, that sort of thing. So let me close that. All right, so we have that. I'm gonna go with this for this function. I think it just looks nicer to do that early return. So we get the output. That'll be handy for when we are setting up the meta heads. So we have all that hooked up, which should tie into this. And then we need meta head. So we need to actually implement and split out that stuff. Set output. Or do we immediately want to? We have the interfaces. We have all the outputs. We could have a... We have it. Let me double check. What are we doing for the adding of heads? Because that actually should be... We have the head added, but it's this generic one. So all these should be swapped over to just generic. which is not this. It's this one. So we want a function for adding the head, I think. Let's see what we're doing here. Configure. Yeah, we'll do this. Virtual void add head. And this will take in a... Do we want to have it take in a meta head? Let's take a look at the function for this. So once the head is available, we just do an append. But this would enable us to control, of course, when we actually want to add the head. So we create the, yeah, we're going to do it this way. Meta head. We'll like that. Got this. And we're going to go output manager here. Oh boy. This all needs to be fixed as well. What's it erring on? Configuration. Did I miss one? Redefinition of meta head. Ah, shit. Yeah. I'm gonna comment that out. To do Josh Strobel. Not like anyone else works on it, but you know. Make a generic configuration. I don't know if that's necessary, but for now we'll comment it out. And configuration here will be dead. We'll rip that out. And where we have WLR, we're gonna rip all that out too. Then we need a function for void. Why is it? Oh, just fucking. What is it doing? Let me delete this and then have it save the file. It can't decide whether it wants tabs or spaces. First world problems. Add head of meta head. Head. So we have that, right? And then we want to create a auto shared head. Shared head of Q shared pointer of meta head to head. Append the head and emit head added on shared head, and then well, we'll just do it like this for now. Q shared pointer meta head. Function style cast auto. Oh, maybe it needs the full definition. BD outputs meta head. Function style cast. Shared pointer of head. But what is M heads here? You list a Q shared pointer. Alright. Let's do this. M heads. Ah, I'm adding the wrong thing. There we go. Wait, that doesn't fix this line though. Outputs meta head. No matching conversion for function style cast of meta head to Q shared pointer. But this is just a normal meta head. right? Like if I do this, it's functionally the same. All right, we're gonna just leave that as is for now. So this ZWLR v1 head would then do an add head of shared, no, of just head actually. And then that converts it to just a shared pointer of the meta head. Oh, but it's doing a shared pointer of, right. No, actually that would be okay. So we don't need to do any of this. Keep that logic there. So when the head is available, what is triggering head available? Emit head available. When we are setting the WLR head, we are emitting this. So we set the WLR head, which then checks if it's the same. If it's not, we create our head from the WLR one. Do a shared pointer to head, and then admit that the head is available. Right, because it's a new one. So we, yeah, create that. Then we map to all these. But this doesn't mean it's ready. But in the meta head, let's see. We have this property changed. So basically we just need to wait for the meta head set property. Oh yeah, I really ripped out all that. Okay, set property, here we are. So when we get the name, that is when we want, so we do an emit, we want to attempt to get the output, auto output, KD output is equal to state, : I think it's a singleton, right? Instance. Oh crap, how do I do this? State : yeah, state instance. We'll do it up here. Auto state equal to oh, maybe that's not necessary. State instance, but we do need to pull it in. Outputs state. And then when we get down to name, we do state get output instance get it's this get output by name with the m name. If KD output not equal null. Actually, I think it's as easy as is null. We'll do is valid. If it's valid, we will do m output is equal to KD output. Because that is, yeah, okay. So then that maps that. All the other properties don't matter. Because we would be getting all of that from the KD thing. which means we don't actually need to save it, I don't think. Yeah. So that's actually going to clean up a lot of our meta code. So let's do that. Let's just clean up immediately. Make model name. All could be deleted. Description. That could be deleted. Identifier we still need. Output should exist when we're doing things. I hope. Identifier change, all of that. Yeah, I guess we might want that to be a proxy for... Oh, do we want the duplicate events? I suppose it's handy for the other things. This will be handy as well. Okay. I think I have a path forward on this one. Metahead CPP. Include metahead.hpp. And then we have a namespace of BD outputs. And we're going to have our constructor, which is going to be metahead, which is going to take in a queue object of parent. Just what queue object parent, yeah. Object parent. I think that's basically it. I don't think we need the rest. I don't think we need to do anything related to QDBus context because that's provided by the class info and all that. So we have that. And next we are going to want the get adaptive sync. So uint get adaptive sync. Of course, it would help if I actually did get metahead. And it's going to be get adaptive sync. So if m output. I feel like I want a private function for like if it's ready. Because I don't want to do this comparison over and over and over and over again. So we are going to have a private bool has output. We're going to do bool metahead has output. Yeah, actually I do need to set. Wait, so we have registry here. Probably not even using it. What are we even using it for here? Literally nothing. I don't think that's right. I feel like we would have been using it for... Really? Oh, I guess not. Okay. I'm going to rip that out. Output modes, that's valid for now. So we're going to want to do this. M output is just empty. M identifier, which is a Q string, view. So that will be, basically it's just an empty string. M output modes is a queue list. Queue shared. Just, I can't be bothered to do a queue shared pointer. Alternatively, what I could do is types. We have all this stuff. I was thinking I could reduce my, like, I could just have a meta mode list. But Yeah, fuck it. You know what? We're gonna do that. What does this consist of? So we're gonna do type def of queue list include outputs WLR. First, now it'll be meta mode from WLR. And it's going to be meta mode list. So now that, and then we're also going to have one for think meta head list. Meta head. We're gonna call this meta head. Include. I'm concerned that's gonna get circular, but we're gonna find out. Outputs meta head. Oh yeah, because if we then import this, it'll be oh crap. Types. We're just gonna import its own meta head. Okay, we're gonna. I don't want to do this. I want to avoid that. And I'm just gonna do this definition up here. Gonna go clear up here. I'm gonna do. What's the way of doing the multi-line ones? Isn't it literally just you do class meta head? Because then you just redefine it. We're gonna do meta head list. Like that. So that'll clean that up. Because then I don't have to redefine everything being a... Actually, and this is the queue. Meta head shared. Do shared list. And then on meta mode, which we have here, I'll do a type def of meta mode. So we're going to do class meta mode here. And then we're going to define this as meta shared. Probably something like that. And wherever we have... I mean, this could have been type def as well. Shared as like shared meta mode. Type def. Shared meta mode. Shared meta mode. Like that. Because then what I could also do was up here, I could have type def q shared pointer meta head as shared meta head. And then this can be cleaned up meta head. Shared meta head. Like so. And then here, wherever we have these defined, oh, just these two. Actually, what we'll do is we'll find all references to this one first. And we will do meta mode shared list. It doesn't know what that is yet. Hopefully it will learn. Come on. Did you mean WLR meta share? Oh, yeah. WLR. This is true. Yes, it's fine. Where else were we referencing this? Up here. Yeah. Because it's still under that namespace. But what we could do now is we have these. Can just be WLR shared meta mode. That cleans that up. It's so much better already. I want to go to I want to fix this immediately. Types. This Where else are we using this? So this is going to be a meta head shared list. So good. And then this is going to be a shared meta head. Nice. All right, with that sidetrack out of the way, because I did not want to have to define this again, we are going to do M output modes. If I go all the way down, this was a WLR. Yeah. Can I do it like this? M outputs? Oh, it's just missing the comma. Okay, but the answer is yes. M current mode is technically yes, but no. Shared meta mode. And that's all busted up, but that's okay. So bool has output, right? So this is literally just going to be a function that returns if M output, which is just going to be is valid, which I believe will, so at C true if managing a WL, but I want to double check the Q shared pointer is valid. Because is it doing a, there's is null. Where's the is valid coming from? If it's managing, shit, yeah. So this also needs to be M output dot is null. So this could be not null, and it's managing an output. Is precisely why I wanted to do it this way. So if as output, so if we don't have an output, I want to return this as a, right now we're doing as a uint 0. I would prefer to, actually wait, no, because there's no concept of the sync with this. Because God forbid we have, you know, built out functionality like that in the core protocol. So this is just going to be 0. So we're going to assume that's the case. Actually, now that I think about it, it's going to be 0 all the time, isn't it? Because we have no, like, even when we have the output, we have no knowledge of what the adaptive sync capability is. Like, sure, we have refresh rate. We could infer something, but that doesn't mean anything. So we're going to go return 0. Easy. And we're just going to add a comment here. We don't, let's see. WL output has no information on adaptive sync capabilities. So we have that out of the way. Now that's one function that we're done with. Now it's built in, which is a Boolean built in. That's a good question. Can we infer that? I mean, not exactly based off this, but I think we do it based off, if I check our meta head, we do M built in. We defaulted to true, which is interesting. Oh, that's built in. We get the identifier, and then if we have a serial, right? So for whatever reason, the internals don't get a serial. So it'd be like EDP-1 is what, like if you had a laptop, the internal panel on it wouldn't have a serial. It's just a name. like EDP1. So if we had the identifier, I mean, this is something we would override with the WLR1 because we would actually have information on this. But the name could be if we could try to infer. Return name. So what we could do is if has output, or if we don't have an output, return false. So we have no way of knowing. And then what we could do is if we do have an output, we check output name is equal or contains starts with EDP, return something like that. I think that might be it. If I feel like David might have a log. I could also check actually my laptop. I won't. I'll check to see if the log is available for it though on C4JO. It might be one that's already fixed. Was it? It might have been a fixed one. Crash on resume DPI. Recompiled headers. Ah, it was this. Yeah, because his reports. HDMI A. Oh, wait, no, that is. So this is on his laptop. So A1. And then. We'll search for head name. EDP. Okay. So his was EDP as well. I mean, I could say like it's just EDP-1. But I get the feeling there's going to be some insane scenario where no, actually no, we will do it. I was thinking like, you know, those that have like the funky laptops that have like the secondary built-in screen that also is like a touchpad. I think I've only ever seen that with like Windows stuff though. I don't think it actually works on Linux, but or if it does, I'd be really surprised if it did. Well, we'll do this. Let's see, there isn't a serial, so we just try to determine this based off the name. The alternative is to check if it starts with DP or HDMI. And then, but it's like, what else would the EDP report as? Because then you also have to think about like VGA, you know? I think it's just easier to report as EDP. And I don't have any old enough laptops to, well, maybe my Asus, but I feel like that would also report as EDP. This'll be enough for now. And like besides, we'll be able to overwrite it anyways. It's the whole point of them being virtual. Let's see. BD outputs output mode info. It's this. So if we yoink that, so we have a current mode, which is the shared meta mode. I don't know if we need to do that either though, because we have modes here. But does it have information on what the current mode is? As a list of the modes. Scale, refresh rate, and geometry. The ID is just a queue string. So if we don't have a current mode defined, otherwise we convert this one to a debug structure, which is the ID is the correct ID. So we could actually do something a little bit smarter here, because we don't have the information about the mode ID, but we might be able to get information based off the current geometry, which we haven't been doing before, about what the quote-unquote current mode is. So we would do something like this. If, and then what we could do is override this. Kind of funny it being a const override. I do it like that. So if we don't have a mode, return current mode. Is this then going to be the parent? Because it's overriding, but all right, I have to double check that VS documentation for virtual functions. Let's see. Invoked by base. Invoking class. Public booking. Well, I suppose I could cast itself. Does that make any sense? I'm wondering if I would do something like this. If we don't have a mode, then auto generic head is equal to const cast of this into a ed outputs meta mode meta head. This and return generic head. Static cast. That static cast of meta head. If I did this. Current mode. I don't know if that'll work. Oh, my music ended again. Apparently we've been streaming for a bit longer than I expected. That's okay. We're in a flow. Can't stop. Not yet. Soon. We'll stop soon. We're gonna do output. So this would actually just be, I mean, we have to circle back to this once we have generic information, in which case we can convert that to a debug structure. But even so, the name, our name actually isn't especially unique either. So if we don't have a current mode, we can literally just do it based off the geometry. And what we could do is auto, let's do this, auto geometry, convenient, let's see, for global position and pixel size. Yeah, that's exactly what I want. So we're gonna do width is equal to pixel, so it's gonna be m output pixel size auto geometry. We'll do size. Size is equal to this, and then we'll do size width. Oh, what is the relative width one? Oh. Auto height is equal to size dot height, and then the refresh rate. Auto refresh is equal to refresh rate. The ID is going to be an amalgamation of all those, because I actually do that with the mode. So if I just go into the mode code, the ID, MID, which is MID is equal to, yes, you could see here, we have an arg of that. So nothing special there. Width dot arg, height dot arg. Can you specify multiple arguments? maybe not. And it will be, it says ref there. Oh, refresh. Okay, refresh. Refresh. All right, and then we're gonna do width, height, refresh rate. Like so. This is complaining that height, which is from that, is an int. Ah, no, it's complaining about this. Output mode, we'll just call this default, not empty, default. Oh shit, that's a, we'll call it I, or just call it info, fuck it. Info. There, it's much better. Then no matter what, we'll still have a useful thing. But we'll need to fix up the mCurrent mode. For now, it's fine. We have on MetaHead output as well, which, I mean, that's literally just returning itself. So we'll do, output here. I'm using this a lot as well. Here's what I could do. K Wayland slash, I think it's client output.h. And we're gonna do a type def of this to be a shared output. It'll be shared shared KD output. Actually, no, K output. So let's find all references to this thing. And we're going to call it shared K output, because that is much shorter. And I also want to find it in some other files. Close this. So it's in MetaHead, which we have saved, and state.hpp and cpp. Right. Oh yeah, I guess I could do also a type def for this. Q list of shared K output is a shared K output list. Then what we'll do is we will find all references to this. Hopefully not. We're gonna exclude ** types.hpp. Because it would be really dumb to immediately replace that. Toggle replace, and we're going to replace this with shared K output list. And Bob's your uncle. All right. Save those. And then the next thing we want to do is still find references to the Q shared pointer with the output, and just change this. And that'll clean up a bunch of stuff too, which would be really great. Oh, I love type defs. Hopefully they won't bite me in the butt when I'm reading this code, 2 months from now or something. Have this meta and state. We're going to ignore that for now. So we have current mode done. And then next is going to be description. So we're going to do string, meta head description const, and this is going to be if don't have an output, return Q string view. right? To a Q string. I thought Q string view was the way of doing it. Is that not right? Q string. I remember Q Latin 1 string view. With the read-only subset, right? I get the feeling as output. Meta head description. This argument member function has const. Function is not marked as const. Okay, well, we'll worry about that. You know what? Q string. Yeah, I mean, I guess it isn't constant. It's probably wanting it to be declared here. I mean, I know it's declared there. Has output const. Out of line definition. Bool meta head has const. Oh, okay, we just haven't updated. It's not really const, but you kind of have to lie to QDBus for it. So this is what it is. Otherwise, we're going to return m output description. So that fixes that. And I mean, a lot of the other functions are going to be quite similar. Enabled. Do we have information on whether or not it's enabled? Is valid, I guess, if it's managing it. Yeah, I guess it's the meta head. So we're gonna do bool enabled meta. Actually, we'll do meta head enabled. And in this case, we're going to return if, well, I guess for one, if we have if has output, if we don't have an output, it's not enabled. If we do have an output, we're going to want to do if output is valid. So I would say if it's not valid, we do that. And then if it does, I would say at this point, if we have it, we should probably just check, does it have a global position and size? And actually, maybe even just setting pixel size and position would be okay. I think we will do that. We'll first check if m output. Do this if m output dot pixel size is empty. So return false if the size is 0, 0. But it's complaining about that. Ah, yes, because there should be an if. If the size is 0, 0, Claim it is not enabled. I mean, the size, actually, position, it should be allowed to be 0, 0. Refresh rate, if it has no refresh rate, if M output refresh rate is equal to 0. I mean, I bet a lot of this is not even necessary. No refresh rate. It's likely not outputting anything. I'm trying to think anything else. I think I don't want to do it based off if modes is empty yet. Actually, what? I want to check the QRect. Because this will have both size and, yeah, so returns true if the rectangle is empty. An empty rectangle has a left that's greater than right or top that's greater than bottom. An empty rectangle is not valid. Is empty is equal to not valid. So is valid. I think mine is probably fine, to be honest. I don't know if I need to do it based on geometry. This is probably okay. And return true. Like, I mean, if it goes beyond that, height. I mean, these are just helpers around the dimensions. But we will do int meta head height const. If we don't have an output, return 0. Otherwise, we will turn m output pixel size 8. Horizontal anchor, right. This one is not something we have. Oh, let me check. What are we doing here? Horizontal anchor. Is that just returning a toString of m horizontal? Yeah, it is. Okay. Do we store that here? We do. So let's rip these out just completely. Do this. Like so. So we have vertical anchor there as well. Identifier is going to be a fun one. QString, meta head, identifier. Const return. If we don't have output, I don't really want to return. I don't want to return an empty string because I just know that's going to trigger conflicts with something like shit overriding itself in different positions. So we'll just have that. Could do it based off like machine ID and what other I mean, if we don't have an output, which is just based off if m output is null. Physical size, subpixels, name. We could do it just based off the geometry. It sounds kind of dumb, but No, actually, because we don't have information, it has to basically be random. Like Q, is there a Q random generator? Arbitrary values, it might be a little overkill. I just want to generate a string, you know? Q random generator, seed value. It doesn't need to be a secure value. So this returns, just a freaking helper for this. Global generate returns that. And then I could just convert it. 32-bit. Okay. It was what? System or global? What's the difference between them? Should not be used for bulk data generation. Seed, we don't have to worry about that. What's global though? Seeded using securely seeded. We use to create random data without the expensive creation of securely. Right. Sure. Q string of this. Is he gonna pull it in? No. Alright, fine. I'll just frickin' go up, and it's probably just this, yeah. Something like that. Doesn't know how to convert this. I guess it would be what, 2 string? Was it return? I mean, come on, it should be able to convert the QUint. No matching inversion from an unsigned into that. Is there really nothing for like random? Hold on, cute random string. From 2018, how to generate. So somebody mentions a list of random. That's dumb. It's like a random shuffling thing. I don't need it to be alphabetical, like alpha, you know, A to Z characters. Q string. I guess what I could do is this .arg like that. Otherwise, the identifier is the m output m name. So it'd be name. So if we don't have one, then we return just a random string, which is just a random number converted to a string. Otherwise, it's the name, because that's the only information we have. So that would likely be like HDMI-A-1 or something, which is, I think, fine for most cases. Identifier. So next up would be make. As output. This I'm fine with literally just returning a Q string. Otherwise return m output make. Is it make the same as? Hey, what is make then? Make. Manufacturer. Why didn't they just call it manufacturer? Okay. Mirror of. Yeah, we'll just do that. Implement when available. Now this, what we could do is we would have to get all the outputs from the output manager. And so we would get the output manager from the state, get all the outputs, and determine if, like, I know how I would do this. I don't really want to do it now, but although I feel like I'm going to brain derp otherwise. We have to check for the intersection. So if the rectangles are intersecting or overlapping fully, and the names, like the identifiers, are different. So we will do, am I doing this? I'm doing this. All right. Output manager is equal to state, which we need to pull in. And it's going to be the singleton, which is, I think, instance. Output manager. Get output manager. Really? Get manager. There we go. For auto output of output manager, we need one for get heads. I guess it is just heads. For each head, if head dot identifier is equal to identifier. Although it actually just occurred to me, M identifier. This is not going to be stable if we do it like this. So we need to do it like this. Oh, fuck. Why you do it? Stop it. There we go. So if M identifier is set, dot is, it's not, if it's not empty, we return M identifier. Otherwise, we set M identifier and we return M identifier. What are you complaining about? Protected string, no overload for equals. Is it? It's protected. Same thing. What? What are you talking about? All right, we'll do it like this. Else. Could clean this up. Identifier is equal to this. And then we would do the return. So if we have one, we return it. Otherwise, we construct it. And this we'll actually want to do or has output and M output name dot is empty. This is a Q string here. Should I? No, it definitely should be protected. I don't think it's supposed to be private. Right? If I move this to private, does that fix it? No. I didn't think so. So why is this then? Oh. Redefinition of meta head. All right, we'll clear that out then. Oh, because meta head is pulling in. Oh, state is pulling in meta head, so I can't have meta head pull in. I have a solution for this. We have meta head defined here. This is just the normal one. Where is it pulling in? I mean, I understand this is all sort of busted up, but configuration doesn't. Right, pull in configuration there, so that fixes that include. I mean, yeah, these should be swapped out. Oh, actually, huh? This should be the shared meta head. Like so. Redefinition of meta head. Redefinition of meta head. Because it pulls in meta head. What I could do is rip that out. This is the WLR configuration. And then define class meta head. So instead of pulling it in. Oh, I wouldn't even want to define it here, would I? But I want to define it at this level. I think. And then rip out meta head here. I don't understand why that's complaining. If I go clear back to this. So we have state. Let's see. Make my light here dimming. Let's see. State. Is included. Only virtual member functions can be marked override. All right, well, what is the issue here? What am I overriding? I don't think I'm overriding anything. I feel like it's so far down the rabbit hole. Ah, strip that out. Okay, so that fixes all of that, but does it fix this? No. Okay, well. That's a bit puzzling. So no viable overloaded equals. What am I doing wrong? Private queue string of M identifier provided by outputs output manager. What? Outputs all? But if I go to it, we have M identifier here. Let me just spam save that. I don't know. I feel like there's something going wrong here. But maybe that's a good time to call it. We've gotten pretty far with porting this over. You know, I've been like slowly pulling bits and pieces out, and I would say it's been a lot of brain work, you know. So I thought it would be much easier, but isn't that the classic thing with developers, right? They over or underestimate. Typically, they underestimate how much is going to be involved. But I completely forgot how much was tangled up in all this WLR stuff. But hey, I'm making these generic interfaces like I had planned on doing. So at least we're doing it right. So I'm quite happy with that. Let me go ahead and swap back over here. So let me go to this. If you like what I'm doing, if you like Budgie Desktop, of course, you're always welcome to head on over to buddiesofbudgie.org. And you're also welcome to donate to us on our Open Collective at opencollective.com/buddies-of-budgie. And this money typically goes to infrastructure. So, for example, this 4JO that we have here as a clear way of trying to move away from GitHub, you're welcome to take a look at our blog that we did, I believe, in the State of the Budgie on 2025. If I do 4JO, you could see, yeah, our information related to software forges and continuous integration and continuous delivery. We have our own woodpecker, which is running on ARM hardware. So we're going to be supporting ARM natively from the get-go with Budgie 11. And the best way of doing that is to actually have builds that are, building against that architecture. So if you like that and, you know, you want to help make it so we could afford to get hardware for developers, for example, like if Evan or David need to pick up a tablet or something to do touch testing, you know, and gesture support or whatever, then you're welcome to do that. And yeah, that's going to be it. So thank you for tuning in, everybody. And I will catch you on the next one.